The second half of Chapter 9 has to do with factoring. So today we're going to focus on factoring greatest common factors and factoring by grouping. So by the end of this lesson, you should be able to factor a monomial from a polynomial, and you should be able to factor polynomials with 4 terms. So this word factoring is reversing the multiplication that we just got done doing. So you can think of this as undistributing. So before, I'd give you a number like 3 on the outside here, you would multiply it by 5x, you'd multiply it by 1, and then we'd simplify to this. And then what we just learned is you would take a monomial, so 2x squared, and multiply it by 3x cubed, and then 2x squared times 4, and then we'd simplify those, and that would be our answer. Today what we're going to do is go backwards. You're going to start with your answer, basically. And I'm going to have you pull out something that they have in common or undistribute something. So the numbers 15x and 3 both have a 3 in common, so that's what I'm going to factor out. And if you notice, I ended up with what we started with over here. Same thing for this one. You're going to take like our answer from before, we're going to start with that, we're going to see what they have in common, and then we're going to undistribute it. So greatest common factor, or GCF, is really important. Factoring a number or a term is breaking down a number into its products. So back in the day, if you were asked to do 6 over 8, chances are right now everybody can tell me that it's 3/4 without much thinking. But what you really did is you broke these numbers up. So break 6 down, like if we had a factor tree, and broke it down into its simplest factors, 2 and 3 are as small as it can go. Those are 6's factors. And then we can do the same thing with 8. 8 would break down into 4 and 2, and then 4 would break down into 2 and 2. So 8 is really 2 times 2 times 2. Now the greatest common factor is the biggest number that they have in common, and in this case, it's a 2. Both of them have 1, 2 in common, and then nothing else in common. The top we're just left with a 3, and the bottom we're left with 2 times 2. So this common factor right here, this 2 divided by 2 we know is just 1, and we would say it crosses off. And that's how we're left with 3 divided by 4, because it's 3 divided by 2 times 2. So that's what you're really doing when you are breaking a number down. So now we're going to do that with polynomials and monomials. So when you see something like 3x squared, you should have it in your head that that's 3 times x times x. Or like 6x cubed. 6, remember, breaks down into 2 times 3. And then x cubed means 3 x's. And having these pictures in your mind will really help you with what we're doing next. So this just says find the GCF of the terms of each polynomial. So find the greatest common factor. So let's take a look at the first one, 5v to the 5th. If we break that down into its simplest terms, 5 can't be broken down, but v to the 5th means v times v times v times v times v. And then the next one, 10v cubed. We know 10, if we make the nice little factor tree, can be broken down into 2 and 5. And then v cubed is v times v times v. So the greatest common factor is the biggest thing that they have in common. So they both have a 5. They both have 1, 2, 3 v's. So if we simplified this, their greatest common factor would be 5v cubed. If you come back up here, you can kind of see that from what we started with. 5 and 10 both have a 5 in common. This guy has 5 v's and this guy only has 3, so they both have 3 v's in common. Let's try the next one. 3t squared. 3 can't be broken down, and t squared is just t times t. Negative 18. Since there's a negative there, we know we have a negative 1. And then break down 18 with a factor tree. 9 and 2, 9 breaks down into 3 and 3. So 18 is really 3 times 3 times 2. So then what do they have in common? If we look here, they both have a 3 in common, and that's it. That's all they have. So the greatest common factor between those two things is just a 3. Now the next one has 3 terms, but we do it exactly the same way. So take each term. 4b cubed, 4 breaks down into 2 times 2. We know b cubed just means we have 3 b's there. Negative 2b squared has a negative 1. 2 can't be broken down, and then we have 2 b's. And then negative 6b, again we have a negative 1. 6 we've done a couple times. We know that can be broken down into 2 times 3. And then we just have 1b. So greatest common factor, what do they all have in common? They all have a 2 here, and they all have 1b in common. So our greatest common factor is 2b. And the more of these you do, the better you'll get at finding the greatest common factor just by looking at these. So what I always do is I break it up. I see that there's numbers in b's here. So I first just look at my numbers. 4, 2, and 6. What's the biggest number that they all have in common? And that's a 2. This guy has 3 b's, this guy has 2 b's, and this guy only has 1. So the biggest number that they all have is just 1b. So now that we can find the greatest common factor, let's use it to factor each polynomial. So I want to undistribute this. So when you see this, think undistribute. So I eventually want some number with parentheses, some junk inside. That's my end goal. So we take a look at what we have, 8x squared and negative 12x. And we have to find their greatest common factor. So 8 can break down into 2 times 2 times 2. X squared is x times x. We got a negative there. We broke 12 down. Well, I guess we didn't break 12 down. If we break 12 down, 4 and 3, and then 2 and 2. So 12 breaks down to 2 times 2 times 3, and then there's only one x there. So see what they have in common. We have a 2, another 2, and then an x. And again, if you take a look at your numbers, 8 and 12, what's the biggest number they have in common? 2 times 2, which is 4. And then this guy has 2 x's, this guy only has 1, so the greatest amount of x's I can take out is an x. So my GCF is 4x. That's going to be the number that's on the outside of my parentheses. And now the awesome thing about doing all this work up here is what's left inside the parentheses is what's left over. So basically what I'm asking myself is 4x times what number is going to give me 8x squared? And that number is 2x, because that's what's left over. And then what number times something is going to give me negative 12x? So if I already have the 4x there, all I need is the negative 3. And then double check your answer. Remember, we undistributed, so that means if I were to distribute this, I should end up with what I started with. And I do. So this, what's in the box right here, is the factored form of this polynomial right here. So let's try another one. 5d cubed plus 10d. So break these down. So 5 times d times d times d. We've done 10 before. It's 2 times 5. And we just have 1d. So again, find their greatest common factor. What do they have in common? They both have a 5 and they both have a d. So 5d is going to be what I pull out. And what's left over is 2d's, or d squared, plus 2. And again, remember that you can check your answer. 5d times d squared is 5d cubed. 5d times 2 is 10d. This one looks a little harder just because we have 3 terms, but the steps are exactly the same. Take each term and break it down into its factors. And the more of these you do, the better you'll get at breaking things down. And the better you'll get at just recognizing things. So we broke 12 down over here. It's negative 1 times 2 times 2 times 3. And then we have 2m's. And then 24 is almost like 12, except it's multiplied by 2. So when we do this, it's the negative 1 times 2 times 2 times 3 times another 2, because it's times 24. So then you pull out, what do they have in common? So there's 1, 2 that we can pull out of each of these. And then everybody has a 3, so we can pull one of those out. And then everybody has at least one m, so we can pull those out. So 2 times 3 times m is our GCF, or 6m. So remember, that's what's going to go on the outside. That's what should be distributed back in. And then what's left over is m squared for the first term, negative 1 times m, so negative m. And then negative 2 times 2 times 2. So negative 2 times 2 is 4, times 2 again is 8. And then you can always check your answer. Don't forget to check your answer. Oh, this should be a 1. Sorry. So it should be negative 4. So the next thing we're going to do is factoring by grouping. And we're going to factor by grouping only when we have 4 terms for right now. So 2 groups of those terms have to have the same factor. So if you look at something like this with 4 terms, we kind of forget about these 2 terms for a second and say, all right, what's the greatest common factor? What can I pull out of these 2 things? So we get this. This is what's left over. And then we forget about these, and we say, all right, what can we pull out of 4y plus 12? And we can take out a 4, and then that's what's left over. If what's left over is exactly the same thing, that means you can factor that out, and then whatever's left over, the y squared plus 4, is going to be our factors. So to factor by grouping, look for a common binomial factor. So remember, that's 2 terms of 2 pairs of terms. So twice is what we're looking for. So factor each expression. So I have 4 terms, that's what I need, and then group them up. 5t to the 4th plus 20t cubed. So just look at your numbers, 5 and 20. The biggest thing they have in common is a 5. And then here's 4 t's and 3 t's, so I can pull out 3. And then what's left over, or what do I need to multiply 5t cubed by to give me 5t to the 4th, is just a t. And then this one I need to multiply by 4 to give me 20t cubed. So now forget about that and just look at this. 6t and 24, what's the biggest thing they have in common? And it's a 6. So if you take this, you should just end up with the t left. And then 6 times 4 gives me 24. And this is what makes this work right here. If you do not end up with the same term here, you can't factor by grouping. All the ones I'm going to give you can. So I'm going to factor that out, because both of them have that term in common. And then what's left over is 5t cubed plus a 6. So this is as broken down as I can get that expression up there. Let's try another one. So what do they have in common? Number-wise, a 2 and a 1 just have a 1. 3 w's and 2 w's, so I'm going to take out 2. If I want to multiply w squared by something and get me 2w cubed, I need a 2 and a w. And then I just need a 1 here, because w squared times 1 gives me w squared. And then here, if this first term is negative, you always pull out a negative there. So 14 and 7 both have a 7 in common, and that's it. So negative 7 times 2w will give me negative 14w, and negative 7 times 1 will give me negative 7. So again, double check that you have the same terms here. And since we do, we can pull that out, and then what's left over is w squared minus 7. And if we double distribute this out, we will end up with this here. Remember that all we're doing is undoing distribution. So now for our last problem, we're going to combine the first part and the second part of this lecture here. So whenever you see something with big numbers like this, or anytime you get anything from now on, look for a GCF. Look for a greatest common factor. So if I just look at my numbers, 45, 9, 30, and 6, they all have something in common. If we break them down, we will find that they all have a 3 in common. So I'm going to pull that out. And then if we look at their m's, this guy is 4, this guy is 3, this guy is 2, and this guy is 1. So that means all of them have at least 1 that I can factor out. So this leaves me with 15m cubed minus 3m squared plus 10m minus 2. And now what's inside of these parentheses can be factored further because it has 4 terms. We can keep breaking it down. So forget that the parentheses are there, and let's just look at these terms here. So 15m cubed and negative 3m squared, they both have a 3 in common, and 2 m's. So 15 times 5, and then m squared times another m will give us m cubed. And then to make it look like this one up here, I just need a negative 1. And then do the same thing over here. What do these guys have in common? Well, they have a 2. If I take that out, I'm left with 5m minus 1. And we know that we did something right because these two terms are the same. So I'm going to factor that out. And I'm left with 3m squared plus 2. And then remember that this was what was inside of these parentheses here. So I still need this 3m on the outside, and this is the totally factored form of that guy up there. If we were to double distribute those two things and then distribute the 3m in, we would get what we started with. So you have 2 to try on your own. When it says factor completely, that means find a GCF first. GCF. So it's like the 2 problems I just did. Or it's like the 1 problem I just did. I'm sure you will have lots of questions, so make sure you write them down and we can go over them in class. Enjoy your night.